Now, if you remember last lesson, we were looking at finding the roots of a polynomial. And what we found was, if you've got a domain from A to B with a continuous function, and if the value of y for A and B are in opposite directions, so one is positive and one is negative, then a root must exist between A and B, because you can't get from A to B. If one's minus, negative, and one's positive, then a root must exist in the middle. And so the first method, the iterative methods, is halving the interval. And essentially what you do is you're given 2 points. You're given A and you're given B. And if you find that the values of y for A and B are opposite, so one's positive and one is negative, it means a root exists in there. And therefore we halve the interval. So I'll do an example in a minute, but it's shown here on this diagram. We halve the interval. Oops. We halve the interval, there we go. So A plus B on 2. So in this case, we'd know that A was negative and B was positive. Okay? And then we'd sub in A plus B. Now in this case, A plus B on 2 is actually the root. So you'd get 0 for the answer. But let's have a look at the next one. A is negative, B is positive. So I halve them. A plus B over 2. And I sub that in and I get a negative. Therefore, you've got to choose, does the root lie between A and the halfway point, or the halfway point and B? And it's based on the signs. So if A is negative and the halfway point's negative, there's no root there. But if A is negative and B is positive, there's a root there. And so we're restricting the domain now. So now we know the root lies in this region. We started off in this region, and we've reduced it. And then you go again. So you halve A plus B on 2 and B, you get the halfway point, and then you keep checking. We'll do an example now. Okay, the first example of halving the interval is given here. The function f of x equals x cubed plus 4x squared plus 1 has a root somewhere between x equals minus 4 and x equals minus 5. Now before we even go on, if you have a look at this function, it's not a quadratic, you can't take a common factor, there's no difference of two squares, hard to factorise. So this is from the other lesson where we're trying to find the approximate area of the root, not the exact root. And the question says, halve the interval twice to find an approximation to the root. So when they ask you find an approximation to the root, there's two methods. Halving the interval, and they'll say halve the interval, and the other one is Newton's method, which we do next time. So what does that mean? Here's your Cartesian plane, and I'm not worried about what this function looks like. We know there's a root somewhere between minus 5 and minus 4. Okay? It could go the other way, could go down. So what we're going to do is find f of minus 4 and f of minus 5 and then halve it. So just to check that, f of minus 4 is minus 4x cubed plus 4 to minus 4 squared plus 1. So we need to know the sign of the endpoints, because in a minute we're going to halve it and we're going to see which half it's in. Is it between minus 4.5 and 4, or minus 4.5 and minus 5? So if I work that out, that's minus 64 plus 64 plus 1. So the answer to that's 1, which is bigger than 0, it's positive. Okay? And if we just do f of minus 5 here, it's minus 5 all cubed plus 4 of minus 5 all squared plus 1. So it's minus 125 plus 100, so 25 times 4 plus 1. which is minus 25, minus 24, which is less than 0. So it's true, there is a root between minus 4 and 5. F of minus 4 is positive, which is somewhere there, and f of minus 5 is negative. So it's this first one I drew. So I might actually just rub this. Can I rub that one out? Can't rub that one out. Okay, so it's this bold one. Anyway, here. Something like that there. Okay, so now we're going to halve it. So if you don't know how to halve it, add the two numbers and divide by 2. So minus 5 plus minus 4 divided by 2 is minus 9 on 2, or simply halve it, minus 4.5. And now on the next page we're going to go and find f of minus 4.5. Okay, so we're going to find f of minus 4.5. So it's minus 4.5 cubed plus 4 by minus 4.5 squared plus 1. Now I'm going to guess it's negative, but I'll do it. Minus 4.5 cubed is minus 91.125 plus 4.5 squared times 4, so it's a positive. It's plus 81 plus 1. Yeah, it's negative because we've got a minus 91, but we're only adding 82. So it doesn't matter what the number is, that is less than 0. So if I have a look at the interval, I've got minus 5, minus 4 at this end, and I halve the interval. And I'm simply finding the signs. So if we think about what we did on the last page and this page, minus 4.5 is negative. So it's somewhere down there. Okay? Minus 4 was positive, and minus 5 was negative. So therefore the root must lie between minus 4.5 and minus 4. Okay? Because to get from minus 4 to minus 4.5, it must cross the axis. So we've narrowed it down a little bit. So now we know the root is somewhere in here. We started out thinking, or knowing, that it was between minus 4 and minus 5. But we've now eliminated this area. There's no root there. So the question said initially, halve the interval twice. We've halved it once, now we're going to halve it again. So how do I find halfway between minus 4.5 and minus 4? I add them up and divide by 2, if you didn't already know what it was. And it's minus 4.25, or minus 4.25. So now, f of minus 4.25, and we check what the sign is here. And with the help of the trusty Casio I've actually got on me at the moment, an old one, it's minus 76, we'll just round up 0.77, minus, that's a plus, there's a square there, so plus 4.25 squared times 4, 72.25 plus 1, and again, there's minus 76, and we're only adding minus 73. So that's negative. So if I draw my interval again, minus 5, minus 4. We found minus 4 was positive, put an X, and minus 5 was negative. So we know there's a root there. We then halved it, minus 4.5. We found minus 4.5 was also negative. It doesn't matter what the number is. So we decided there's no root there. It must be in between this area here. And the question told us to halve it again, which we did, and it's minus 4.25. And we found that was also negative. So we can cross off that area, and we can say that a root exists between minus 4.25 and minus 4. So we've narrowed it right down from minus 5 to minus 4, which the initial question said. We've halved it once, halved it again, and the root lies somewhere between minus 4.25 and minus 4. And we could keep going. And eventually, okay, it will, well it could take forever, but it's somewhere in between minus 4.25 and minus 4.